Hello, ladies and gentlemen. My name is Matthew from the Guided Hacking YouTube channel, and welcome to your first tutorial on the C programming language. Throughout the next, 10 to 20 videos, I plan on filling in those blank spots you guys might have in the C programming language to help out you guys follow through the other hacking videos on this channel. Because I figured a lot of you guys come to this channel maybe without enough C or C++ experience, so we're going to fill in those blanks today. But we are going to be doing it in Linux. So I'm going to assume that you guys have, enough experience on the terminal or enough experience to at least follow along what I'm doing on the terminal, because I don't plan explaining that stuff too much. But besides that, let's just get started and write some code. So I'm going to go ahead and just create a little project folder here super quick. I'll say hello world, I guess, if I can type. There we go. Perfect. Then inside there, I'm going to create a main.c file so we can write our code inside. Perfect. I'm going to open up my text editor. Let's go there. Perfect. Don't know why that's doing that. Perfect. There we go. All right. So the first thing I sort of want to do is write a very basic C program and then go over it with you guys exactly how it works. So I'm going to go ahead and do that. All right, there we go. So let's start from the top. So what I'm doing here with these double slash is writing a comment. Comments are great for when you need to either take notes on your code or if you're writing code that other people are going to have to read. The comments are a great way for you to just type literally whatever you want so other people don't have to try and read and understand your code, allowing that person to essentially understand your code faster, if that makes sense. I hope it does. I use it for notes all the time, and I recommend you guys do too. So here I'm going to say include. Let's say include standard input output files for the use of printf. Okay, so we're going to talk about printf in a sec, but we can't write this line of code if we don't have this, because printf, what is called as a function, this function belongs to stdio, so we can't use printf unless we include stdio. All right, next thing. I'm going to write a comment here. Define process entry point. And what this is saying here is that everything between this bracket and this bracket is the main function, or where your code starts execution. So inside these brackets, it's first going to run printf, and I guess I'll just explain what printf does. Printf simply just prints out text to a terminal, and return 0, exit process. That's all it does. Inside these two brackets here, first thing we do is we print out text. Very simple. We can't use printf unless we include stdio, because printf belongs to stdio. And then we exit process. It's simply read inside these brackets, top down. It's as simple as that. I can go here and put another comment. We'll say print out text. Perfect. So now let's try running this program. So in your project folder, you can use a compiler, GCC. If you don't have it, just go install it. Main.c -wall-o, and I'll say hello. So the -o operator allows us to name the program when it outputs, and -wall will check for all warnings. It's as simple as that, and obviously the first thing is the name of our .c file. So it's going to take our .c file now and convert that into an executable that we named hello. So let's go and test that, and it does exactly what I said it would. It would print out hello world. So I'm going to remove this /n because this might confuse you, but I'm going to show you why that /n is there. Let's recompile it, rerun it, and you see how it doesn't go down another line? That's what that /n does. That \n is going to make sure that it goes down another line. It's simply called a new line character. It's as simple as that. All right. But besides that, I'm not going to spend too long on the extreme basics. We're going to get right into some variables and types. So if we want to, actually, I guess before I go into variables and types, I'm going to quickly show you guys how to print out a number. So I'm going to write 1 plus 1 equals, and then %d right here. And if I want to print out the number where %d is, I can now say like 1 plus 1 right there. I'll compile that, and you can see 1 plus 1 got replaced with %d. I'm going to write another thing here. I'll say 2 plus 2 equals %d. And then here I'll go 2 plus 2. And it will take 1 plus 1 and put it in the first %d. Then it will take 2 plus 2 and put it into the second %d. So let's go and save that and test that. It's as simple as that, guys. I mean, I'm trying to show you that you can do arithmetic. I mean, I could literally also just put 2, and I could put 4 here. Sorry, that's a 3. There we go. And it will do the exact same thing. All right. I hope that makes sense. So I'm going to erase that. And we're going to create some variables. So we're going to make a variable called int a. So what int means is we're creating a variable that has to be a number, and then we're giving it the name a. And we're going to do the same thing with another one. We're going to call it b. So we have two variables named a and b, and they can hold a number. It's literally just like algebra. And just like in algebra, we can set a and b to values. I'll set a to 3, and I'll set b to 7. It's as easy as that. It's probably looking a lot like your algebra right now. So now I'm going to write a printf statement that sort of like prints out this equation. So I'm going to write %d plus %d equals %d slash n. And I'll just put a, b, and then a. Actually, I don't need to do parentheses there. A plus b. Perfect. And I'll explain this real quick. A is going to go to that %d, so it's going to say 3. And then b is going to go to that, it's going to say, 7. And then it's going to do a plus b, which is 10, and 10 is going to go there. So it's going to print out, let me clear this. It's going to print out an equation. Yep. So I can change these numbers. I'll change that to 10 and change that to 6. Simple as that. And it will automatically change the equation for us. So to cover this again, I'll say create number variables. It's probably the best way to explain it. Set variable values and print equation. Just like that. Now, I'm doing this the long way. What I can do is if I erase this, I can also do this. And in the declaration, that's what this is called, is I can give it values. Like that. See, it still works. Perfect. So you don't necessarily have to use multiple lines to do simple things like that. Another thing too is you can declare multiple variables in the same line by adding a comma, and then I can say b equals 10. So there, now we've shortened it all down to one line. We have declared two variables and we've set their values. As you can see, that still works. So perfect. Let's talk about some other data types. There are other variables called chars, which let's just call it letter. You can also, if I didn't explain, your variable names can be how many letters you want. They just can't be some certain special characters. But it doesn't have to be like a single letter like A, B, X, Y, whatever. I'm naming this variable letter, and I can set it equal to the letter Y. So if I were to, in printf, I want to print out the letter Y, I can do it like this. Say letter equals, and then %C for characters. And I can just put Y. No, I mean, sorry. Letter. There we go. Clear this. Oops. There we go. Letter equals Y. Perfect. There's another data type for you. Another one would be float. We'll say float pi equals 3.1415f. And for float, it's %f, and we'll say pi equals, and then simply just put pi. Perfect. So pi will go to here and replace that %f. And one thing that's strange with floats that you've now seen is that you have to put an f at the end. I'm pretty sure there are different versions of C where you don't have to put the f at the end, but I was taught to always do that, so I still always do that no matter if it's in a newer C++ or whatever. When I use floats, I put an f. So make sure that's saved, compile, and run, and there you go. Cool. So let's talk a little bit about memory. So I'm going to erase this. 1 byte is 8 bits. Like that. Like 0, 1, 0, 1, you know, you get it, 8 bits. To make up an integer, a normal integer on a 32-bit system is going to be 4 bytes. So this is literally how many zeros and ones you are storing for that number. So a normal int would say, I don't know, int num equals 4, right? That is this much data. Now, if we don't need this much data for a number, we want to say have a 2 bytes, you know, because here, I'm going to pull up a list super quick to give you an example of how big a 4-byte number can be. So I'll say int sizes on Google super quick. So a normal int can actually go up to, I'm reading here, like 2 billion something, whatever. It's like 2,147,483,647. Now, one with 2 bytes, a short int, you can only get values up to 32,767. All right, and that would be number ranges for 2 bytes. It would be, you know, negative 32,768 to 32,768 on a normal short int. Now, if let's think of this. Let's go back to our normal integer here. So this one is, oh god, this is a big number. It's gonna be negative 2 billion to this with a normal 4-byte integer. Now, if we don't need negative numbers, what we can do is we can make this variable unsigned. And what that'll do is it's still a 4-byte number, but instead it's going to be the values 0 to, let me get this number for you guys, to 4 billion whatever now. It literally doubles. It takes that leftover negative and adds that to the doubles, effectively doubling its maximum positive value. That's sort of, I hope that makes sense. And if you don't need a number that's negative, but you need it to count really high, go ahead and use an unsigned. But you can still, you can like tie these things together. You can have a short unsigned int, which is, you know, gonna take that, and it's like 0 to like 64,000 something. It's like 0 to 64, yeah. So, and you can do that with floats also. I don't remember how many bytes a float has. It might have 4 or 8. It's one of the two. We'll look at that another time. I know doubles are 8 bytes, so I'm pretty sure a float would be 4 bytes. So if you want to have a float, a decimal number that can have more decimals on it, you can have a long float, if that makes sense. I hope it does. Okay, but I hope that makes sense with data types. I'm going to quickly give one more example, though. You can set, like, if I had int a equal to 4, I can set int b equal to, like, a plus 6. So you don't have to only use numbers. You can use variables in your arithmetic also. But there's also, like, division. There is multiplication. There's modulus. All the fun stuff. Subtraction, addition, like we already talked about. you're pretty much free to experiment with the operators that you're normally used to experimenting with. So, all right. Besides that, I think we are free to continue on to the next topic here. Let's talk about constants. So, a constant, if we have a normal integer, we'll say int num equals 4. Now, because this is not a constant variable, we can, we can change the value of number. So this would be an effect. This would be a way for me to like add 4 to num. So like num is equal to itself plus 4. So like I'm adding 4 to num. But this statement here would become invalid once I make it a constant int. You see how I get this error here? It's because it's a non-modifiable value. We need to have a we can only modify non-constant values. So let's say like, I don't know, we're writing a multi-threaded program. We can have constant int threads and set it equal to 4. And we know we want it to be constant because we don't want the amount of threads to change. Basically, if you don't want your value or your variable to change, make it a constant, and it will not allow the programmer to modify that data value. And that's pretty much it for constants. I actually forgot something. Besides short int, there is also like long. Long is another one, long int, which would make it from 4 bytes to 8 bytes. I just wanted to make sure I mentioned that also. But yeah, let's go ahead and think about what we can do for a last example program. I think I'm going to show you guys how to input to a variable. So I'm going to make a variable num here, just like this. I'm going to default it to a value of 0. And I'm going to say printf, please enter a value for num, like this. And now I can call scanf, which is another function that belongs to stdio, which will allow us to get user input and basically get user input to a variable. This sort of makes sense. So now what I can do here is go %d for num, and then what I need to do is give the address of the variable. So we're not going to talk about pointers and addresses for a while, which is another subject, but for scanf to work, you need to give the memory location of num. And that's what this symbol means. It's the memory location of num, because scanf, if you look at it, takes it actually doesn't say it. It shows the ... because it's using an arg thing, but I just know that scanf needs an address because that's just how scanf works. Scanf needs an address to the variable that you want to write over with the user input. So step 1 here, we can say create variable. Say printf here, we'll say, we'll say get user input, like that, and then we'll say print results. We can call printf again, and I'll just say num equals %d/n, and just say num. Perfect. All right, so I'm gonna explain scanf again real quick to make sure that's really ingrained in your guys' brain, that for scanf to write to num, it needs to know the address of it. Like, imagine if you're going to your friend's house and you only know the neighborhood that he's in, but you don't know what his actual address is. You wouldn't be able to find his house very easily. But if we give the address of that house to, said person or variable, right, then they can just go right to that address. So that's what you can think about with scanf, is we're given the address for scanf so it knows where to write the inputted data. So let's compile and give an example for this. So do that, /hello, please enter a value for num. I'm going to say 16. and it says num equals 16. Perfect. So that is all that I plan on doing for today, but make sure to catch me in the next video, I guess, and I'll catch you guys later. See you guys.